Good afternoon. We are going to discuss a DT video based upon a synthetic fingerprint generator. And now we are going to discuss about the what are the empathy part will be happened here, and then define ideal prototype. Now we are going to discuss in the brief manner.
So good morning, ma'am. I would like to start from the problem statement. According to our analysis, so real-time fingerprint raises a privacy and protection problems according to GDPR. GDPR is General Data Privacy Restrictions according to the European Union. Then people with unreadable fingerprints are excluded from the biometric systems. And coming to the synthetic fingerprint generations, the currently available and existing models are failed to generate a really existing fingerprints. So it's not clear when we come to the pixels of the generated fingerprints. So for that we have came up with the idea of a synthetic fingerprint generator. So seeing the empathy part, we would like to develop a synthetic fingerprint generator with AI based models. And so coming to the define part, as a proposed model, we are using TSFG. It's one of the main framework in visual learning models, and it's not widely used around the currently using existing models of synthetic fingerprint generators. The existing models only use GANs. GANs is the general adversarial network models. It has two parts, one is generator and a discriminator. The purpose of the generator is to generate a fingerprint which looks similar. And discriminator, what it will do is it always takes the original image and the generated part. It satisfies only when the generated part is similar to the original one, not the exact one. So in this process, a generator would fail to generate the similar fingerprint model, and discriminator always rejects the model, and the final output has some defects in it. So what will happen? We can't use it in real models. So our proposed system is with the TSFG, transformer based synthetic fingerprint generator. So it also uses submodels. I will explain it later. So coming to the process of our model, first we will collect the data and save it as a file called class A.TIF. TIF is nothing but it's a file format which can store high HD images. So coming to the pre-processing, we will pre-process the resize the images we have previously stored in the IFT. We will resize it 120 into 120. Why we are resizing means each image has its own size. So model will take a lot time, and we have it uses large source of energy to process these data. So we are resizing it for a smooth and easier process. Then coming to the random rotation and flipping, we have to rotate. Actually, it's all done with the AI model. It also rotates the real fingerprint from left to right or right to left, and flips the center part of the fingerprint as up to down or down right to left side. It is used for generating the synthetic fingerprint as a real model. And grayscale conversion, I will show you an example. Grayscale conversion is nothing but just taking the outer core lines of the real fingerprint and sketching it as a synthetic fingerprint to match the original one. This is the pre-processing process, and makes these items are shifted into the SFD model architecture. As I mentioned before, TSFG is the base framework for synthetic fingerprint generation. It also has the transformers It also uses the vision transformer. Vision transformer acts as an encoder, which encodes the pixel into 16 into 16 boxes, and it converts the images to 56 dimensions. Then it sends this to the fully connected layer of the network. What it will do means It converts the encoder part as a vectors like features what we will use in neural networks. Then coming to the final part of the creation, it will move to the convolution neural network decoder. As it mentions, it's a decoder, it fully decodes the encoder part and rebuilds the fingerprint. Here is the actual building of the synthetic fingerprint image generates. It also decodes the vectors and creates it as a final image. The final image will be moved to the training process. Here we use a loss function, MSE, mean square equation error, and SSIM, LS, etc. The loss function is used to reduce the errors which have generated in the processing area, and mean square is also used to reduce the errors. SSIM is a process of checking the pixel values which it is clear or not. The SSIM value should be less than 1. It states that your image is perfect for the usage. So coming to the evaluation matrix, it also checks the original feeder image to the regenerated or recreated synthetic fingerprint. If it is okay, when the value is equal, it approves to use the synthetic fingerprint, or else the process starts again.
I have a doubt.
Yeah.
If you are having already the fingerprint will be gotten by the people, means it will be converted as a synthetic fingerprint, or a upcoming we are getting for a live session we are getting a fingerprint, right? That one will be only after for synthetic fingerprint, or a previous already we are getting.
No, ma'am. We are using
Long days ago.
Yeah. We are using for currently we are using the data sets like SACO. SACO is one of the famous fingerprint data sets. It has more than 6,000 files around the world. It's all collected from the sources like legal sources like criminal department and the forensic department. These fingerprints are mostly related to the people who are died or collected from the crime places. So we are using that currently we are using that. In future we have some idea of collecting the real fingerprint from the person and modifying for the particular device for the easy process and privacy matters. Then
Thank you.
that was